Understand the state of dynamic equilibrium. Initially, the reaction system H2 plus I2 is in equilibrium with 2HI is at a state of dynamic chemical equilibrium. At dynamic equilibrium, the rate of the forward reaction is exactly equal to the rate of the reverse reaction. Rate forward equals rate reverse. Analyze the immediate physical change to the system. When additional I2 is introduced into the rigid reaction vessel, the concentration and partial pressure of reactant iodine molecules immediately increase. Apply collision theory to the forward reaction. Collision theory dictates that the rate of a chemical reaction depends on how frequently reactant molecules collide. Increasing the concentration of I2 molecules means there is a higher density of reactant particles in the container. This physical change increases the likelihood and frequency of collisions between I2 and H2 molecules, which is the necessary step for the forward reaction to take place. Consequently, the rate of the forward reaction immediately increases. Analyze the immediate effect on the reverse reaction. Immediately after adding I2, the concentration of the product, HI, has not yet had time to change. Since the concentration of HI is initially unchanged, the frequency of collisions between HI molecules remains constant, meaning the rate of the reverse reaction does not immediately change. Compare the reaction rates to determine the net direction. Because the forward rate has increased while the reverse rate is initially unchanged, the rate of the forward reaction becomes greater than the rate of the reverse reaction, rate forward greater than rate reverse. This establishes option C as the correct answer. Over time, this inequality will drive a net forward shift to produce more products and re-establish equilibrium. The correct answer is option C. The rate of the forward reaction becomes greater than the rate of the reverse reaction.